Okay, we're going to be looking at the solutions to the Math 100 midterm. So let's look at this first problem. Just try and get the angle a little bit better. Maybe. Okay. So if I'm going to solve this, there's nothing in front of these parentheses, so I can drop them. But with these parentheses, there's a negative sign in front. I have to distribute it through to every term. So this becomes minus 2x, and then minus positive 2, so minus 2. So now I've only got one x cubed term, but I've got an x here and a minus 2x. So 1x minus 2x is minus 1x, just minus x. And then I have negative 2 minus 2, which is going to be minus 4. So I need to find the answer that looks like that. And my solution to number 1 is A. So this is the 100 midterm. All right, find the x-intercepts of the function shown above. All right, the x-intercept is where the graph crosses the x-axis, and it crosses it right there. And that is the point 1, 2, 3, 0. So that's where my x-intercept is. And there's only one place where it does that. So the answer to number 2 is A. Number 3, find the y-intercept. So I'm looking at where this crosses the y-axis. It crosses the y-axis here. And what are the coordinates of this point? Well, the x-coordinate is 0, and the y-coordinate is negative 1, 2, 3. So that is the y-intercept. Okay, this selection A is where the x-intercepts are, and the question was find the y-intercept. So the answer to number 3 is D. Okay, now number 4, we need to find the domain. I've been given a formula, and we are not allowed, the formula is a fraction, you can't have 0 in the bottom of a fraction. So whatever is in the bottom cannot be equal to 0. So whatever's in the bottom is not allowed to be equal to 0. So if I add 5 to both sides and keep the symbol, this is saying x is not allowed to be 5. And think about it. If x is equal to 5, this becomes 1 divided by 5 minus 5, which is 1 over 0, and that's not allowed. So x is not equal to 5. Now, that's the correct answer, but we have to find the form it's been written in. It's not written up like this. So what does x not equal to 5 mean? Well, on the number line, if this is where the number 5 is, then it's not allowed to be 5, so I exclude it, but it can be anything else. So this is a number line, a pictorial representation of that answer. So this and this are the same answer. But this is not written in this form or in number line form. So if it lives in the red, it's allowed. Now, what does that mean in interval form? Well, going from left to right, we don't have a leftmost point here. So we're going from negative infinity up to, but not including 5. So I have to put a parenthesis there. Then we jump over 5, and we take it up after 5. And then there's no limit on this side. So this is what it looks like in interval form. And so that's what I'm looking for. So the answer to number 4 is B. Okay, so continuing along, let's look at number 5. What is the domain of this function specified below when it is a set of ordered pairs? Then the domain is going to be the set of the first coordinates. If we had been asked for the range would have been the set of second coordinates. But we've been asked for the domain, and so we're going to look at this. So the domain is going to be the set of, well, my first coordinate is 6, then 8, then 10, then 12. And that is my domain, 6, 8, 10, and 12. Okay, notice here, that would have been the range if they had asked us for the range instead of domain. And some years on the final, the question will be but domain. Other years it will be range. This year on the midterm, we've been asked domain. Now don't forget the final is cumulative, so you could see this question again, but they might ask you for the range. So the answer to number 5 is B. Now let's look at number 6. What is the domain of the function whose graph is shown below? Okay, when we have a picture of a graph, the domain, well, how do you find the domain? You use the x-axis to measure how wide the graph is. From left to right. Okay, so I'm going to use the x-axis, so I'll do this with the red pen. Do we have a leftmost point? Because we're going from left to right. Yes, we do. It's colored in, so it's included. So I'm going to use the x-axis to measure how wide this is. And as I'm moving from left to right, all of these points are included. I don't have any gaps. And does this keep going? Yes, this keeps going forever. So what I've drawn there in red is the domain. I've used the x-axis to measure how wide it is going from left to right. And where does this start? Negative 1, 2, 3, 4, 5. So it's starting at the point negative 5, 0 and going on forever. Now, these are not points. These are intervals. So how can I describe this? Well, if I'm on the number line, it starts at and includes negative 5. So what I've written here is the point, negative 5, 0. But as an interval, this starts at negative 5, and it's included. So in interval form, I'm going to start and include negative 5, so I need this square bracket. And I keep going forever. There are no gaps and there is no rightmost point. And so this is the answer that I'm looking for. So make sure I did it correctly. 1, 2, 3, 4, negative 5. It starts at negative 5. Okay, so the answer to number 6 is C. Number 7, find the range. If we have the graph of a function, how do we find the range? Well, we use the y-axis to measure how tall the graph is from bottom to top. So again, in my red pen, where is the bottom? There. And where does that point correspond to on the y-axis? Right here. And we're at 1, 2, 3, -4 on the y-axis. And now if I use the y-axis like a tape measure to measure how tall this is, I'm starting at -4, and I don't have any gaps. And I can see from the arrows here that's going to keep going forever. So what I've drawn here in orange is the range. And now I need to put it in interval form. We start at and include -4. And then we go up. There are no gaps and it keeps going forever. So that is going to be my range. The answer to number 7 is B. Okay, now suppose f of x has this formula, find f evaluated at -2. So what I'm going to do is I'm going to rewrite the formula for f, and I'm going to replace the x's with blank parentheses. Everywhere there's an x, I'm going to put blank parentheses. And now what do I want to find? I want to find f evaluated at -2. So inside those parentheses, I'm going to put a -2. Now, once you do that, you can put this in your calculator exactly as it's written there, as long as you include the parentheses. So you don't have to do it by hand. Let's turn this on, clear that. So parenthesis, negative symbol 2 squared plus 3 times -2 minus, so the subtraction sign, 2, and then print enter. So I'm getting a -4 from my calculator. If you've done that by hand, -2 in parentheses all squared is +4. So I have 4 minus 6 minus 2. So that would have been 4 minus 8, which would have given me -4. But I get the answer just the same. So I'm looking for the answer -4. So the answer to number 8 is D. Okay. So moving along to next problem. So we're up to number 9. The graph of the function f of x is shown. And find the interval where the function f is decreasing. Now, it's decreasing. This happens whenever we trace over the graph from left to right. It's decreasing if we are going downhill. Okay, so if I trace over this graph from left to right, uphill, 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 flat road, but between here and here, I'm going downhill. So this is where it's decreasing, but I have to describe where that happens. And the way I describe where this happens is I use the x-axis. So I'm going to use my pen. It's decreasing. It starts decreasing here. This corresponds to, that begins right there on the x-axis. So it starts decreasing when x is here, and it stops decreasing when x is here. So in between these two x values is where it's decreasing. And what are these two x values? 1, 2, 3, 4, 5, then 6, 7, and 8. So it is decreasing when my x values are between 5 and 8. That's a correct answer. In interval form, x is between 5 and 8. It's interval form. That is not a point. It's an interval. Okay, it's this interval. So the answer I'm looking for is answer B for number 9. Number 9 is B. Number 10. The graph of the function is shown. Find f evaluated at -1. So from the lectures, we have that f evaluated at an x coordinate of a point is equal to the y coordinate of the point on the graph of the function. So we need to find the point on the graph with x coordinate -1. And we see this point here has x coordinate -1. What's the y coordinate? The y coordinate is 2. So we can see that -1, the point -1, 2 is on the graph. So it's on the graph of f. Therefore, f maps -1 into 2. F evaluated at -1 is equal to 2. And so that is the answer that I'm looking for, 2. So the answer to number 10 is D. Number 11. Find f evaluated at 2 for the function given in this form. Well, again, f of the first coordinate is equal to the second coordinate. So this tells me that f of 1 equals 4. This tells me f of 2 equals 7, and that's what we want. So what is f of 2? I can stop right here. F of 2 is equal to 7. And so the answer to number 11 is B. Okay. All right, let's keep going. Okay, this is a transformation problem. So here's the graph of f. Which of the following graphs is f of x plus 1 plus 3? This was the lecture where we made the chart, the cheat sheet chart, and said you absolutely had to memorize it, that there would not be a formula. You could just put in your calculator and see what the graph is. So I want to start with the graph of f of x, and I want to get to this. Well, one change I could make would be to just tack on plus 3 to the end. And from our cheat sheet for transformations, what change do I get from going from here to just tacking on 3 at the end? We go up 3 units. Now, I'm no longer working with this. I'm working with this, and I'm trying to get it to look like that. What change do I make? I replace the x inside the parentheses with x plus 1. Now, if the change I have made from here to here is to change x inside the parentheses with x plus 1, then the transformation is it shifts it left 1 unit. So the horizontal transformations, as was said in the lecture video, do the opposite of what you think they'll do. So if it's just plus 3 tacked on at the end, it's up 3. But if inside the parentheses x has been replaced with x plus 1, it's a shift to the left 1. So what do? We start with f, we go 3 up, and then we go 1 left. So if I take this and go 3 up, 1, 2, 3, and then go 1 to the left, so 1, 2, 3 up and 1 left, then I'm going to have something that looks like that. And so I can tell just from where this point is, it's got to be B. It can't be anything else. So the answer to number 12 is B. Okay. All right, the graph of f is shown below. Which of the following graphs is 2 times f of x? Well, again, there was a cheat sheet for this, for the transformations, and it had to be memorized. So what is the new graph going to be look like? Well, if the old point is x comma y, then the new point is going to be the same x coordinate, but if this number is outside, the y coordinate will be changed by multiplying it by the number that's outside. So let's get some points that are easy to identify. What is this point? What are the coordinates? 1, 2, 3, 4. So -4, comma, -2. So what's the new point going to be? Well, the x coordinate does not change, but the y coordinate will. It'll be 2 times -2. So the new point will be -4, comma, -4. So I'm going to draw the transformed graph in the same one with a red pen. What about this point on the old guy? So that has coordinates -2, comma 2. So what's the new point going to be? The same x coordinate, but the new y coordinate will be 2 times the old y coordinate. So -2, comma 4. There's the new point, and so I'm going to draw a line between those. Okay. This point is easy to identify. What are its coordinates? +2, +2. So what are the new coordinates going to be? The same x coordinate, but the new y coordinate will be 2 times the old y coordinate. So that's where the new guy is. And then finally, what are the coordinates of this point? 1, 2, 3, 4, comma, -2. So what will be the coordinates of the new point? It'll be the same x coordinate, but the new y coordinate will be 2 times the old y coordinate. And then I'll join those together. So that's what the graph of 2 times f of x looks like. And if I look at these selections, there it is, selection D. Okay, so what I've drawn in orange is the same as selection D. So number 13 is equal to D. Okay, number 14. Which of the following is the graphs of negative f of x? Well, if you have a negative out the front of it, it's going to be a reflection. And if you're never sure if it's an x reflection or a y reflection, then try it with the square root of x. So let's look at the square root of x. Okay, and let's just see what the graph of that is. And now what happens if I make the change by just putting a negative symbol out the front? And if you can't remember, oh, does it swap it around? Does it reflect it in x or reflect it in y? Look what it does to the graph. Okay, so there's the square root of x, and if we put a negative symbol out the front, it's reflected in the x-axis. Okay, so that's a good check. So I want to take this and I want to reflect it in the x-axis. So if this point is looking in the mirror and the x-axis is the mirror, its reflection will be here. If this point's looking in the mirror, its reflection is going to be down here. The same kind. So it looks like I'm going to have something like this. Okay, so that's what I need to look for in the orange. And just be really careful. It can't be this because look where that point is. It's above the x-axis. And look where this is. Okay, so it's clearly aligned with selection D. So the answer to number 14 is D. So let's get our. Okay. All right, let's look at number 15. Let's solve this for x. Okay, so I'll rewrite it out here. Just do a focus. There we go. I need to solve for x. I need to get x by itself on one side of the equation. So I'm going to add 5 to both sides of the equation. So these will go away. And I have 12. Now to get x by itself, I need to divide both sides by 4. Because then they will cancel and I have x is equal to 12/4, which is 3. So x is equal to 3. And so my solution to 15 is D. Okay, let's look at number 16. We need to solve this for x. So let me write it up here at the top. Okay, first of all, I need to write this without parentheses. So the 3 has to be distributed through everything inside. So I'll have 3 times x plus 3 times -1 equals 4 times x. So this 4 has to be multiplied by everything inside the parentheses, so the distributive properties. So 4x plus 4 times 1. And then don't forget your -6. So I have 3x minus 3 equals 4x, and then 4 minus 6 is -2. Now, I want to get everything with x on one side and everything that doesn't have x on the other side. So there are different ways you could do this. One way is we can add 3 to both sides. When I add 3 to both sides, I have 3x on the left-hand side, and over here I'm going to have 4x minus 2 plus 3, which is plus 1. And now to get everything, my x terms on the left-hand side, I'm going to subtract 4x from both sides. 3x minus 4x is -1x, or just negative x. And this is what negative x is, but I want to find out what x is. So I have to negate both sides, or multiply both sides by -1, because this has got to be x. So -1 times -x gives me x, and 1 times -1 gives me -1. So I have x is equal to -1. So the answer to number 16 is B. Find the slope. So it's just the slope I want to have between these points. Well, the slope is equal to the change in y over the change in x, or the difference of the y values, so y2 minus y1, divided by the difference in the x values. Now, it doesn't matter which one you start with. I'm just going to take them as they come. So I'm going to call this point x1, comma y1, and I'm going to call this point x2, comma y2. And so this will be y2, which is 10, minus y1, which is 4, divided by x2, which is 6, minus x1, which is negative 1. So x2 minus x1, 6 minus negative 1. So in the top, 10 minus 4, I have 6, and in the bottom, I have 6 plus 1, which is 7. And so this is my slope, 6/7. And so the answer to number 17 is D. Okay, now I need to find the equation of the line containing these points. Write the answer in standard form. Okay, first thing I have to do is get the slope. So again, I'm going to have x1, y1, and I'll call this x2, y2. So the slope is going to be y2 minus y1 over x2 minus x1, which is going to be y2 minus y1 all over x2 minus x1. So the slope is going to be negative 3 minus 0. So I have negative 3 in the top. And 0 minus 4 is negative 4. Now, these negative signs cancel. And so the slope is 3/4. Now, this point is our y-intercept because the x-coordinate is 0. So that's our y-intercept. That's been given to us as a gift. So that means that the b is equal to negative 3. So y equals mx plus b is the slope-intercept form of the line. Y equals 3/4 x plus negative 3. This is correct, but I need it in the standard form. Okay, so what I can do is I can add 3 to both sides. I can subtract y from both sides. And now I can multiply every term by 4. So multiply everything by 4. 4 times 3 is 12. 4 times 3/4, the 4's cancel. And 4 times negative y is minus 4y. And now I just need to swap sides. So if a equals 20, you can write it as 20 equals a. I just swap sides. So if 12 equals 3x minus 4y, then 3x minus 4y is equal to 12. 3x minus 4y equals 12. There we go. So the answer to number 18 is B. Okay. Number 19, find the equation of the vertical line. From the lectures, you must remember a vertical line has equation x equal, not y equal. Y equal is a horizontal line. So from the lectures on vertical and horizontal lines, first thing you got to remember, as soon as it says vertical line, it's x equal. And it's x equal, well, what is the x coordinate of this point? 5. And so that's going to be our answer. So where is 5, 2? There it is. And so the line that goes through this point is going to be x, the vertical line, equal, well, where does it go through the x-axis? At 5. So the answer to number 19 is C. Find the slope and the y-intercept of this. Well, let's put it in slope-intercept form. Okay, I'm going to subtract 5x from both sides. So when I do that, my line becomes minus y equals 7 minus 5x. Now, I'm just going to swap the order of that. So negative y equals, I'm going to put negative 5x first. Now, it's almost in slope-intercept form, except I got to have y over here by itself, not negative y. So multiply every term by negative 1, or negate every term, so change the sign of every term, however you want to call it. So negative 1 times negative y gives me y. Negative 5x times negative 1 is 5x. And positive 7 times negative 1 is minus 7. Here's the form I need. That is the slope. And negative 7 is the y-intercept. So the slope is 5, and the y-intercept is negative 7. So the answer to number 20 is B. Okay, what is the slope of the line that is perpendicular to the line with this equation? Okay, this line has slope. Well, it's in slope-intercept form, so this line has slope n equals 3. Now, any line parallel to it would have the same slope. Because on the final exam, you might get the exact same question, but it might say parallel instead of perpendicular. A perpendicular line, so the one that this question is asking for, has slope, well, it'll be minus 1 over whatever m was. So that's the general formula. So it will be the negative of 1 over 3. So a perpendicular line will have slope negative 1/3. So if this question was, what is the slope of the line that is parallel to the line with this equation, the answer would be D. But for perpendicular, I have to take the slope, flip it, and negate. And so we have the answer B. The answer to 21 is B. Use your calculator to fit a line to the following data. Round your slope and y-intercept to the nearest 100th. Okay, so we had these in the video lecture, and we have to use our calculator with this. So let's make sure I've got some lists cleared. So let me clear out list 1 and list 2. Okay, you can go to Stat, go to the editor. Now, in the first list, I want all of my x coordinates. So 1, 2, 3, and 4. And in the second list, I want my y coordinates. So I could do 0.8 or just 0.8, because when I hit enter, it'll have it as 0.8. If I do 0.58, if I hit enter, it's just going to put it as 0.58. So I've got 0.35 and 0.18. Okay, now I've entered that in. Then I press Stat. I scroll over to Calc. And I come down here to number 4, LinReg, linear regression. And what do I want to do? I want to use linear regression if my x values are in list 1 and my y values are in list 2. If you have a newer model, you get a picture and you just have to enter them in separately, a vertical picture. But it should be the same entry. So now it's telling me what the line is. The line is y equals a times x plus b, where a is equal to negative 0.209 and b is equal to 1. So I'm going to write all of this together to get my line. Y is equal to A, the red A, which is negative 0.209 times X, plus B. Now, it said to round it to the nearest hundredth. Everything is rounded here to 2 decimal places. So if I round this to 2 decimal places, that becomes, well, that's a 9, so that gets bumped up to a 1. So that's what I'm looking for. Okay, and 1 is the same thing as 1.0, so here it is. That is what I want. So my answer for number 22 is B. Okay, continuing. Let's look at number 23, solving the inequality for x. So we would solve this much the same way as we would do it if there was an equal sign there. The goal is to get x by itself, preferably on the left-hand side. Okay, so what I'm going to do here is I'm going to subtract 1 from both sides. So this will give me that. And then finally, to get x by itself, I'm going to divide both sides by 2. So the 2's will cancel here, and I'll have x is less than 9. Now that is a correct answer. But you can see that the selections here are in interval form. So what does x less than 9 mean? Well, if it's on the number line, and 9 is there, then we do not include 9 because of the symbol. X is less than 9, but it's everything to the left. Now, in interval form, so what this means, if x is in the red, it's good. It's allowed. Interval form, going from left to right, we have no leftmost point over here. There's no limit over there. So that's going from negative infinity up to, but not including 9. So if it does not include 9, if it's not colored in, I put a parenthesis there. This is not a point. This is an interval. So this is what I'm looking for. And so as we can see on number 23, that is C. Number 24. When we have an inequality like this, the goal is to get x by itself in the middle. So let me rewrite it over here. And also pay attention to your symbols there, because they include equality this time. Okay, now the goal here is to get x by itself in the middle. So what I'm going to do is I'm going to subtract 5 from everything. So these go away, and I'm left with negative 4x in the middle. And subtracting does not change the direction of the arrow. So over here I have negative 7 minus 5. I've got a negative 12 there. And over here I've got negative 9 minus 5. So that gives me a negative 24 there. Now I want to get x by itself in the middle, so I'm going to divide by negative 4. But here is where we must be so careful. When you divide by anything negative, it changes the direction of the arrows. So negative 24 divided by negative 4 is positive 6. These cancel. I'm left with x. And negative 12 divided by negative 4 is positive 3. So x is between 6 and 3, inclusive. Or I could write it like this. So if you swap these in, the symbols change as well. So on the number line, what does this mean? Well, x can be 3 or anything larger than 3 up to including x equal to 6. So if it's in the red, it's good. So in interval form, what does the red mean? I start at and include 3, and then continue and stop and include 6. That is my interval. And we can see it's matching selection B. So number 24 is B. Number 25, multiply x minus 5 all squared. And if you did x squared minus 25, x squared minus 5 squared, that is wrong. Because if it's a plus or minus in here, you can't, that rule does not count for that. You're confusing the exponent rules. Those are only for when what's inside the parentheses is multiplied. This is x minus itself, x minus 5 times itself. And you have to FOIL. So if I start with x, I have x times x is x squared. X times negative 5 is minus 5x. Then I'm done with that. And then negative 5 times x is negative 5x. And negative 5 times negative 5 is positive 25. So I have x squared, and negative 5x minus 5x is minus 10x, then plus 25. That is what the answer to number 25 is. 25 is D. Now we should be at or before the 1 hour mark, because this is a 2-hour exam, and this is exactly what you'll have on the final. A 2-hour final that's all multiple choice. So the way you should pace yourself is when you get to number 25, you should be at an hour or before. So that's a good way to mentally check if you're on target for finishing this on time. Okay, now what is A in union with B? A in union with B is the big set made up of both of them. So just write down both of them. Now, set notation means you can have no repeats. So now what I have to do is just get rid of the repeats. So I have a 2. Is there a 2 anywhere else? Nope. And what comes next? A a 5. I'll just go through it as it is, a 5. Is there a 5 anywhere else? Nope. Then comes a 6. Is there a 6 anywhere else? Yep. So I'm not going to write it twice. Then I've got an 8. Then I've got a 4. And then I've got a 7. Now, this is a correct answer. That's correct. But when I look at the selections, they're all done in order. So there's no difference. So I might want to write it in order now. So there's the 2. Is there a 3? Nope. Is there a 4? Yep. Is there a 5? Yep. Is there a 6? Yep. Is there a 7? Yep. And is there an 8? Okay, so this is what I'm looking for. 2, 5, 6, 2, 4, 5, 6, 7, 8. So the answer to number 26 is C. Now, what is A intersected with B? That is only the stuff that's in both. So let's put A, and then right underneath it, let's put B. So is 2 in both? No. Is 5 in both? No. Is 6 in both? Yes, it is. And is 8 in both? Yes, it is. So I'm done. So the intersection will be 6 and 8. There it is. So the answer to number 27 is D. What is the complement of A? The complement of A is the stuff in U that's not in A. So let's write U, 1, 2, 3, 4, 5, 6, 7, 8. And let's write A, 2, 5, 6, 8. So 1 is in U. Is it in A? No, so it's in the complement. 2 is in U, but it's in A, so we don't include that. 3 is in U. Is it in A? No, so it's in the complement of A. 4 is in U. Is it in A? No, so it's in the complement of A. 5 is in U, but it's also in A. 6 is in U, but it's also in A. 7 is in U. Is it in A? No, so it's in the complement of A. 8 is in U, but it's also in A. This is the complement of A, 1, 3, 4, 7. So the answer to number 28 is C. (29) Which of the following equals this? Well, why don't beneath each of these we write out what it is without parentheses, and we stop until we find the one that equals this. So if I'm going to write this without parentheses, I must carry the negative sign through everywhere. So this becomes negative x minus negative 15. So that becomes negative x plus 15. So it's not going to be this one. What about this? Negative negative x and negative negative 15. So that doesn't equal the same thing as that. It's not that one. What about this? This is negative x minus 15. And it's not that one. So I guess it's going to have to be this one. Negative negative x is positive x and minus 15. And it is selection D. So the answer to 29 is D. Okay, continuing on. We want to simplify this. Okay, our rules say if I've got a power, an exponent on the outside of parentheses, it gets applied separately to everything inside. So I have to apply it to 2 squared, then apply it to x cubed, then apply it to y. Now, the rules say if I've got something outside the parentheses, I multiply those. 2 times 3 is 6. 3 times 3 is 9. And then I've got y cubed. So I'm looking for 2 to the 6th times x to the 9th times y cubed. Okay, so the answer to number 30 is B. 31. Okay. This has nothing outside, so I can write it without parentheses. But this parentheses does have an exponent outside, so it has to be applied separately to everything inside. So I'm going to apply it to -2, then p cubed, then to q. Okay. So this is going to be 2 times p squared times q cubed. -2 in parentheses squared is +4. And the rules here, I multiply. So that's going to be p to the 6th times q squared. And then I'm just going to change the order. I'm going to put the numbers first because this is a product. So I'm going to have 2 times 4. Then I'm going to put the p's together. So times p squared times p to the 6th. Then I'm going to put the q's together, times q cubed times q squared. Now the rules for this, well, 2 times 4 is 8. To get the power of p, I add these exponents. So this is going back to our exponent rule. So this will be p to the power of 2 plus 6. And to get 1 power of q, the exponent rules say you add these. So that will be q to the 5th. So that's what I'm looking for. 8 times p to the 8th times q to the 5th. So the answer to number 31 is D. Okay, now suppose f of x is equal to this. So I have a function. What is x evaluated at? X minus 1. All right, so the first thing I do is I rewrite this, and everywhere there's an x, I put blank parentheses. Now, this is how it was taught in the videos. And what do I want? I want f evaluated at x minus 1. So I'm going to go back, and inside these parentheses, I'm going to put x minus 1. Now, this is a correct answer, but as we can see here from the selections, I've got to work out what that is without parentheses. So again, this is not x squared minus 1 squared. If you do that, your answer is going to be wrong. This is x minus 1 times itself. The exponent rules only apply if you have products inside these parentheses. We do not have a product inside here. It's a difference. Here, I'm going to distribute the -2 through to everything. So I have minus 2 times x. Then -2 times -1, and then minus 1. And now I'm going to FOIL this. I'll have x squared minus x. Then I'm going to have -1 times x, and -1 times -1. I can go ahead and put those together. 2 minus 1 is plus 1. So I have x squared. That gives me minus 2x plus 1 minus 2x plus 1. Now I should be able to put everything together. I have x squared. Then I have a minus 2x and a minus 2x. So that's minus 4x. Then I have plus 1 plus 1. And that's going to be my answer. So x squared minus 4x plus 2. X squared minus 4x plus 2. The answer to number 32 is A. Number 33, what is the range? The range is the set of second coordinates. If it had asked for the domain, it would have been the set of first coordinates, but it's asked for the range. So I've got 19, I've got 18, 18, and 19. But remember, in set notation, no repetitions. Sorry, it's a set, and which is the same thing as 18, 19. So that is the range. So the answer to number 33 is B. What is the domain of this? You cannot have the square root of something negative. So whatever is inside here has to be greater than or equal to 0. So the formula I have is x plus 5 is greater than or equal to 0. But I have to say what x is allowed to be. This is telling me what x plus 5 is allowed to be. So if I subtract 5 from both sides, and subtracting does not change the direction of the arrow, I have x is greater than or equal to negative 5. And if this was in number line notation, it would be like that. So if it was in interval notation, it would be like that. But today, they're asking us for this set notation, and so this is the one I'm looking for. So the answer to number 34 is B. So let's move along to the next. Going to 35. What is the slope and the equation of the horizontal line passing through 5 on the y-axis? Well, first of all, horizontal lines always have slope 0. A vertical line has undefined slope, but a horizontal line has slope of 0. Now, it said it's passing through 5 on the y-axis. And so this goes back to our video on vertical and horizontal lines. So the equation of the line in orange, in red, which is what we want, it's horizontal, so it's always y equals wherever it passes through the y-axis. So the equation is y equals 5, and the slope is 0. So the answer to number 35 is B. Okay, which of the following lines is parallel? Parallel lines have the same slope. But to tell what the slope is, it has to be in Y-intercept form. This is not in Y-intercept form. You have to put it in Y-intercept form. So let's subtract. So which means you have to get y by itself on the left-hand side. So let's subtract 3x from both sides. So these cancel. I'm going to put the x term first. So minus 3x, then minus 10. Then I have to get y by itself, which means I divide every term by 2. So I have y equals negative 3 halves times x minus 10 halves, which is minus 5. So any line that is parallel to this line which is the same as that, will have slope -3/2. That is the slope. So now I'm looking for a line that has slope -3/2. And there it is. That's telling me all I need to know. So the answer to this is going to be C. The answer to 36 is C. Okay, what is the domain? Okay, remember the domain, you use the x-axis to measure how wide. So, do we have a leftmost point? No, we don't. So it's coming in from -infinity and up until we get to 2. Is 2 included? No, it's not. Then, when I'm between 2 and 3, there's a gap. But I pick it up again at 3, and 3 is included. And then there is no rightmost point. So that's what I'm looking for the domain. So the answer to number 37 is B. Now what about the range? For the range, use the y-axis to measure how tall it is from bottom to top. Now, start at the bottom. That corresponds to -8 on the y-axis, and it is included. And as I go up, we've always got points on there. There's no gap at 8 because, sure, that point's not contained, but I've got one over here. And it's going to keep going up forever. So -8 is contained, and so that is going to be our range. 38 is D. -8 was clearly contained. It's filled in. 39, for the function f pictured above, what is f evaluated at 4? Remember, f of the x-coordinate is equal to the y-coordinate. So I need to find the point with x-coordinate equal to 4. And there's the point with x-coordinate 4. What's its y-coordinate? Its y-coordinate is 3. So 4, 3 is a point on the graph. And what does f do? It maps the x-coordinate into the y-coordinate. So f evaluated at 4 is equal to 3. So the answer to number 39 is D. 39 is D. Simplify this. This is another exponent rule. Okay. Now, when I've got a fraction and the whole thing is raised to a power, then it can be applied separately to top and bottom. And I'm going to work top and bottom separately. Now, in the numerator, if this is outside, then to get rid of these parentheses, I apply it separately to everything inside. 2 squared times x squared times y squared, all squared. Same for the denominator. To get rid of these parentheses, I have to apply that to everything inside separately. So it'll be 3 squared times a cubed squared times b cubed, all squared. 2 squared is 4. And then the rule says I multiply those. 2 times 2 is 4. 3 squared is 9. And then the rule says I multiply those. which will be a to the 6th, and then b to the 6th. Now, have I got that anywhere? Actually, it looks like it's missing one. So this should have been E. So that's unfortunate. So I will correct that. So everybody gets credit for number 40. Everybody. So in future tests, I will make sure that that is a correct selection. But that was an error on number 40. That should have been the correct answer. Okay, I've corrected that in the master file, but everyone gets credit for number 40. So I've just marked that there was an error. So future ones won't have the error in it. Okay. Let's look at this. Solve this linear equation. All right. Maybe I can do it all on here. First thing I'm going to have to do is get rid of the fraction. So I need to multiply a half through. So a half times 5 is going to be 5 halves. And then a half times 4 is 2. Now the goal here is to get x by itself on one side of the equation. So here I've got 5 halves times x plus 4 equals x minus a half. Okay, now how about we make things easy and get rid of these fractions? And I can do this, I can still have equality if I multiply everything by the same number. Since these are all, I've got fractions with 2 in the bottom, I'm going to multiply every term by 2. Every term. Got to do it to every term, or you won't have equality there. So 2 times 5 halves is just going to be the 5. So I'll have 5x. 2 times 4 is 8. And 2 times a half is 1. So I get minus 1. Okay, so that's easier to handle. So now I'm going to subtract 8 from both sides. So those go away. And negative 1 minus 8 is minus 9. Now I'm going to subtract 2x from both sides. Make sure that's in focus. And so these go away. And so what I will get is 5x minus 2x is 3x is equal to negative 9. I need to solve this for x. To get x by itself, I am going to divide both sides by 3. So those will cancel. So x is equal to negative 9 divided by 3 is negative 3. So that's my answer. So number 41 is D. Okay, number 42. Decide whether the equation is identity, conditional, or contradiction. Well, let's see what happens. I have to get rid of the parentheses. 3 times negative 2 is minus 6. So I can add 6 to both sides. So these will go away. And then I can subtract 3x from both sides. So these cancel, and those cancel, and I'm left with 0, and over here I'm left with 12. That is not true. 0 is not equal to 12. So if you get down to a false statement, you have a contradiction. So the answer to number 42 is C. Decide whether the equation's identity, conditional, or contradiction. So a conditional is you'll have x equals something. X equals one thing. Contradiction, you'll get a false statement. Identity, you'll have a true statement but no help, like 2 equals 2 or -7 equals -7. Let's see what happens here. I have to get rid of the parentheses, so multiply, distribute the -3 through. -3 times x is -3x. Now, when I multiply -3 times -2/3, well, first of all, the negative sign goes away, and the 3's will cancel. 3 times 2/3 just leaves me with 2. And I've got exactly the same thing on both sides. So, I mean, you can keep going if you like. I'll subtract 2 from both sides. And I'm left with -3x equals -3x. And if I add 3x to both sides, I'm just left with 0 equals 0. That does not solve what x is. So when you can solve for x, you have a conditional. When you get a false statement, it's a contradiction. When you have a true statement, but can't solve for x, that is an identity. So number 43 is A. 44, what do we have here? Well, I have 3x minus 6 equals x plus 6. Okay, so let's add 6 to both sides. So these go away. And now I would like to solve for x. How about we subtract x from both sides? So these go away. 3x minus x is 2x. And now I can solve that for x. If I divide both sides by 2, I'm left with x equals 6. So this equation is true on the condition that x is equal to 6. So the answer to number 44 is B. Now, the formula for the perimeter of a triangle is given by that, where A, B, and C are the lengths of the sides. So perimeter, think of a fence, a border fence around whatever shape you have. So a perimeter of a triangle is like a triangular fence surrounding, say, a triangular property. Assume the perimeter of a triangular plot of land is 240 feet. Okay. And I'll call this A, B, and C. So I've got a triangular plot of land, so the perimeter is 240. And the perimeter is adding up the separate sides of the fence. Okay. Now the longest side is twice the length of the shortest side. Okay, so when in what I've drawn, C is the longest, A is the shortest. So that's just in my drawing. You might have drawn it differently. So what is this saying? The longest side is twice the length of the shortest side. So the longest side is twice the length of the shortest side. And so my middle side, which is B, the middle side, B, is 20 feet less than the longest side. So B is equal to the longest side minus 20. So let me write that over here. So this is what I've got. Find the length of the shortest side. Okay. Let's start with this. So let me write this one again. Okay. Now, A plus, but I've got another way to write B. And I've got another way to write C. Okay, so the parentheses don't matter here. Okay, so I have 240 equals, well, a plus 2a is 3a plus c minus 20. But don't forget, I can use this again. C is equal to 2a. Okay. So I'm going to have 240 because the c is equal to 2a. That's what I put there. 3a plus 2a is 5a minus 20. Add 20 to both sides. So I have 260 is equal to 5a. And now to find a, I divide both sides by 5. And 260 divided by 5 is 52. So a is equal to 52. Now, what was a? A was the shortest side, and I was asked to find the shortest side. So I'm looking for 52. There it is. The answer to 45 is B. Okay. 46. Which of the following functions is even? Do we remember even? Even is the y-axis is a mirror. And so if it's even, you should get reflections, mirror reflections on either side. So it should be this one. If the y-axis is a mirror and this guy is looking into the mirror, his reflection on the other side should look like that. And that is what I get there. So I'm going to say A. I mean, this is not, and it doesn't matter which side you start on. If this guy is looking into the mirror, the y-axis is a mirror, I'm expecting his reflection to look like that, and it's not what I get. If this guy's looking in the mirror, I'm expecting his reflection to look something like that. I don't get that. Okay, so even, it's clearly going to be A. 46 is A. Which of the following functions is odd? The test for odd is turn it upside down. And if it's odd, you get the same, exact same graph. So look at this guy. If I turn him upside down, see, this is like the bottom of the valley here. If I turn him upside down, it's like a mountain. It's not the same drawing. This guy will be odd. Now take a good long look. If I turn this graph upside down, I get exactly the same graph. So you can do this with the other two. This guy will be odd. That doesn't happen here. You got to be very careful. If you turn it upside down, you're not going to get the same graph. Now it has the same shape, but it's not the same graph. Look where this goes over the x-axis, where it makes contact. It makes contact on this side just to the right of 1. That does not happen if I turn it, if I turn it upside down. So it's not the exact same graph. All right, so the answer to 47 is B. All right, nearly finished. Okay. All right, I've got to write this without parentheses. So nothing in front of here, I can just drop them. Now, this negative sign has to go through everything. So minus 13x to the 5th minus negative 7x. So that's plus 7x. Then where are my powers of x to the 5th? There they are. And 8 minus 13 is negative 5. So that's what those give me. Then I have 10x plus 7x. So that's plus 17x. So that's what I'm looking for. So number 48 is D. 48 is D. And 49, there's a negative sign out the front. It must pass through everything. So minus negative 3x is plus 3x minus 1. Then plus 3x squared plus 4x minus 2. So I have minus 2x squared plus 3x squared. So negative 2 plus 3 is positive 1, so that's 1x squared, which is just x squared. Then I have 3x plus 4x, so that's plus 7x. Then I have negative 1 minus 2, so that's minus 3. So that's what I'm looking for, and that will give me selection A. And finally, there's nothing in front of this, so it's just 8x plus 4. Then this negative 2 has to go through everything. So minus 2 times 5, minus 2 times 11x. So I have 8x minus 22x. So that'll give me negative 14x. Because 8 minus 22 is negative 14. Then I have 4 minus 10. So that's minus 6. So I'm looking for negative 14x minus 6. Negative 14x minus 6. So number 50 is D. Okay. So all in all, not too bad. We just left out a selection for 40. Okay, I have corrected that. So in the future, if you're watching this and it's been pre-recorded, I will have fixed that. All right. Okay, so just make sure, try and retake this before the final. The final is comprehensive. The final covers everything. You will see these questions, not the same ones, but ones like it on the final.